So today we're going to talk about the graphs of the sine and cosine functions. And so when we graph sine and cosine, our ordered pairs are coming from the angle on the unit circle. And then for the sine value, it's the y value of the right triangle on that unit circle, or the y value of the coordinate. And then for the cosine, it's the x value of the ordered pairs around the unit circle. And so notice that they both continue horizontally forever in both directions. So the domain for both is negative infinity to positive infinity. Our range for both functions is -1 to 1, including -1 and 1, because the lowest possible value we can get is -1, and the highest possible value we can get is 1, because remember, the radius of the unit circle is 1. And so that's the largest number, and -1 is the smallest number that we can have for the y values of our function. The period is the amount of time it takes to make one full cycle. And so if we start here, then one full cycle will end at 2 pi. So from 0 to 2 pi is one full cycle before it starts making that same pattern again. And that's why we call these cyclical or sinusoidal or periodic functions. Those all mean that it's a cycle that continues over and over. Okay? And so our x-intercepts, here's where they become different. So for the graph of sine, your x-intercept is every integer multiplied by pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, -1 pi, -2 pi, and so on. And so that's where that graph is going to cross the x-axis. For cosine, we are crossing the x-axis at all of the pi over 2 plus n pi. So -pi/2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So all of the odd integers times pi divided by 2. Our y-intercepts for, intercept for sine is the origin. Our y-intercept for cosine is the point 0, 1. Sine is an odd function because you could reflect the graph over the y-axis and then over the x-axis, and it will lay on top of itself. Or you could rotate it 180 degrees about the origin, and it would lie on top of itself. So it's an odd function, and it has the symmetry is about the origin. For the cosine function, it's an even function because it's reflexive over the y-axis. You can flip the whole graph over the y-axis and it will look exactly the same. All right, so let's take a look at some of the pieces of the equation that help us graph the function. So typically our functions are written out as y equals a times sine of the quantity of b times x minus c. And then sometimes you'll see like a plus d outside the parentheses, and that's just giving you a vertical translation, okay? Or you might see y equals a times cosine of the quantity of bx minus c, okay? And we are assuming that b is always greater than 0, because that's going to change our value a little bit if it's not. So our amplitude is the absolute value of that coefficient of the function, okay? Because if it's a negative value, then that actually means that we have a reflection over the x-axis. And so the amplitude is just the stretch, the vertical stretch that our function has. The period is how long it takes to make one full cycle, okay? And we can find that by taking 2 pi and dividing that by the b, the coefficient of x. And then we have a way of finding our left and right endpoints for one cycle. We can set that expression that's inside the parentheses equal to 0. And then we can also set it equal to 2 pi, and that will give us the beginning and the end of one full cycle. All right, so let's take a look at example number 1 and see how we can put this all together. So we know that our amplitude is going to be the absolute value of -1 because that's the coefficient of cosine. So our amplitude is 1, so we don't really have a vertical stretch going on there. The period is 2 pi over b, which in this case b is 3 because it's the coefficient of x. Okay, so it will take 2 pi over 3 units to get from the beginning of a cycle to the end of a cycle. We have a vertical translation of 4 units up. And then finally we have a reflection, because of that negative in front of the cosine, we have a reflection over the x-axis. Okay, so over the x-axis. All right, so let's see what our beginning and end points are. So we take our 3x, because that's our bx minus c, set it equal to 0. And then we take our 3x and set it equal to 2 pi, because that's one full cycle of the normal cosine function from 0 to 2 pi. All right, and so we get x equals 0, and then x equals 2 pi over 3. Now in this case, because we don't have a horizontal translation, our period and the ending of our cycle is the same number, but that's not always going to work out to be the case. All right, so in the normal cosine function, we have a horizontal line of reflection, the line that cuts the graph in half, and that is the x-axis. And so we're just going to graph that x-axis. If I can get my colors, there we go. All right, we're going to graph the x-axis as our line of symmetry. And then we're going to shift that up 4 units. So our new line of symmetry is going to be up here at the line y equals 4. Okay, and then I'm going to graph my normal cosine function. And so normally we would start at 0, 1, and we'd come down and it would cross the x-axis at pi over 2, and then come down to its minimum of -1 at pi, come back up and cross the x-axis at 3 pi over 2, and end up at 2 pi 1. So there is one full cycle of your normal cosine graph. And if we want to graph the other side of it, on the left-hand side of the y-axis, we can just reflect all of those points over and get the other side. And keep in mind that that graph is going to continue forever. So that's what our normal cosine graph looks like. So now we're going to graph the new function that we've created. Okay, and so we know that our center line is at 4. We know that we have reflected over the x-axis. So instead of starting above our line of reflection, we're going to start below. Our amplitude is still just 1, so we know that our first point is going to be the point 0, 3. And our period is 2 pi over 3. So we've already shifted 4 units. So we've taken care of that. Our amplitude is 1. We've already reflected over the x-axis. All right, and so we know that this cycle is going to end at 2 pi over 3, which is approximately right here. And so halfway in between those 2 points would be pi over 3, and we graph the maximum there. And then you can connect those with a curve. And the more you practice, the better you'll get at graphing this. And so then we can graph another cycle. So we go about another 2 pi over 3. And that's not quite 2 pi over 3. So we go another 2 pi over 3. And then halfway in between. And we can connect those. And then we can go one more. Okay, and then we can reflect that over the x-axis to get the next side. And there is the graph of 4 minus cosine of 3x. All right, let's take a look at another problem. Graph the function y equals 2 sine of x minus pi over 2. All right, so we're going to take a look at our amplitude. And that's the absolute value of 2, which is 2. So we've got a vertical stretch of 2 going on. Our period is 2 pi over the coefficient of x, which is just 1. So our period is 2 pi, so that doesn't change. We have a phase shift, which is also the same thing as a horizontal shift. And that is pi over 2 to the right, because remember, when we have minus pi over 2, it's shifting to the right. If it was plus pi over 2, we'd be shifting to the left. And then we can find our beginning and end by taking our bx minus c, which is x minus pi over 2, set that equal to 0, and then also set it equal to 2 pi. Okay, and so we're going to start our graph at pi over 2. And we're going to end our graph at 5 pi over 2, because 2 plus 1/5 or 1/2 is 5 halves. And so that's what we're going to use as our beginning and our end of our graph or our function. All right, so if we take a look at the normal sine curve, we would start at the point 0, 0, and then on the pi's, the whole units of pi, or the integers times pi, we would have our x-intercepts. And then at pi over 2, we would have our maximum, and at 3 pi over 2, we'd have our minimum. So at negative pi over 2, we'd have a minimum, and at negative 3 pi over 2, we'd have a minimum. So here is the normal sine curve. Okay, so now we're going to graph this changed, this transformed sine curve. So we know that we're stretching it by 2 units. Our period is still 2 pi, and we have a phase shift pi over 2 to the right. So we're going to take this point at the origin and shift it over to the right by pi over 2. And so then we can take each of our x-intercepts and shift them over by pi over 2. So we're going to shift them all to the right, pi over 2. Then we're going to take our maximum and shift it over to, or pi over 2, I should say, but we're stretching it up, so we're going up to 2. And so for each of these, we're going to shift them and then stretch it another unit. And so now we have all of our points, and we can go ahead and graph them, or graph the function. And there is the graph of our function 2 sine of x minus pi over 2. All right, let's take a look at the last problem and see if we can find the amplitude, the period, and the phase shift, which is the horizontal translation, of this sine function, and then write the equation of the graph. Okay, so our amplitude is the distance from the maximum to the minimum. So our amplitude is 0 minus negative 2 divided by 2. So it's halfway, half of that distance there. And so we get 2 over 2, so it's just 1. We can find our period by looking at the beginning and end of one full cycle. And so this part is easy to tell because it begins at 0.5 and ends at 2.5. So the distance from 2.5 to 0.5 is 2. So our period is 2. Phase shift, we actually don't have a phase shift because if we're looking at the sine function, it does cross, or it does start at that on the y-axis, but the whole graph has been shifted down. So we have a vertical translation, but we don't have a phase shift. We have a vertical translation of 1 unit down. Okay, and so we can take all that information and use it to come up with an equation for this graph. Now, remember that our generic equation is y equals a times the sine of the quantity of bx plus c. Okay, so we know that a is 1, so we can write the 1 or not. The b, we need to figure out what b is going to be, and we know that it involves the period. Remember that your period is 2 pi over b, and so if our number, our period, is 2, then we can just take this equation and solve for b. So if we multiply both sides by b, we get 2 pi equals 2b. And then we can divide both sides by 2, and so our b is going to be pi. So that is the number that goes in front of the x. That's the coefficient of x. And we don't have any horizontal shifting going on. We don't have a phase shift. So we can actually just close that parenthesis and then subtract 1. Now there is one other way we could write this equation if you want. We could say y equals -1 plus the sine of pi x. Just in case that helps you to see that we are not subtracting that 1 from the pi times x. We're taking the sine of pi x, and then from that answer, we're subtracting 1.